we need to add one more point, which is the middle point between A to B. That will give us n equal to 2. That is single. Okay, how about composite? The composite is n greater than 2. But why when n greater than 2, it needs to be even number? Okay, because if we have odd numbers, we cannot include the midpoint. Okay, can you understand? Boleh faham tak?
Boleh, madam.
Boleh Okay, so
Can.
boleh Okay, so that's why composite n needs to be greater than 2 and needs to be even number. Okay, let's say we said that n is equal to 10. So what you can do is from A to C, you divide by 5. From C to B, we can divide 5. So we will get 10. 5 and 5, we will get 10, which include point C. Okay, let's say if we want to divide into 3, here is A and this is B. Okay, and we have the middle point here C. But when you divide into n odd numbers, okay, you can divide into 3. But the point here, okay, you will get new point here, x1 and x2. But you not include the point C. You tak dapat nak masukkan nilai C tu. That's why n needs always will be even numbers. Okay, if composite. And then for Simpson's 3-8 rule, okay, this formula. Okay, I will show you how to use the formula. And then we look at the Simpson's 3-8 rule. Okay, Simpson's 3-8 rule, it's require 4 data points. 4 points, yeah, 4 points. Okay, that means if you have to integrate from A to B, okay, you need to divide to 4 segments. Okay, which is here we have one point here. Okay, A is the first point, and then we have x1 here, and we have x2 here. Okay, so A we can write as x0, B is our xn. Okay, in this case our n is 3. Okay, so we use first point is A, second point is B, the first and the last limit. Kan kita ada limit, okay, the first and the last one, and then the other two kita kena ambil dekat antara A to B. Okay, but here is H needs to be same value, the step size needs to be same. Okay, so here you can see that our n is equal to 3. Okay, for Simpson's 3-8 rule, single means n equal to 3 because it requires 4 points of data. Okay, when we have 4 points, 1, 2, 3, 4, that means we have n equal to 3. And we don't have composite. Okay, Simpson 3-8, we don't have composite. This is the formula for 3-8 rule. And then one more is Simpson's 1/3 rule and 3-8 rule in tandem. Okay, in tandem that means we combine 1/3 and 3-8. Okay, why we have to combine? Because if we have to divide the segment into odd numbers. Okay, for example you have to evaluate the integration by using Simpson's rule with n equal to 7. Okay, which rule that you can use? Which rule? Okay, first, if you want to use Simpson's 1/3 n is equal to 2, or n needs to be even. Okay, but our case now is n is odd. Okay, so we cannot use 1/3. And then we want to use 3-8 rule. 3-8, n is equal to 3. And we don't have composite. Okay, so how to solve for n is odd? You have to combine these two. Okay, so let's say here kita ada berapa ni? 1, 2, 3, 4, 5, 6, 7. Okay, so let's say you have to solve, you have to integrate by using Simpsons with n equal to 7. What you can do is you need to divide. Okay, you have 7 segments. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, what you can do is you need to take the first 3 yang ni. The first 3 needs to be 3, 8 or the last 3 needs to be 3, 8 rule. Okay, for this example you can see we choose the last 3 segment, solve by using 3, 8, and then the first 4 segment yang tinggal the balance, if you take it 3, you will get even. The balance will be even number. Okay. When you take 3, the last 3, you use 3, 8, you can see that the balance is we have 1, 2, 3, 4. 4 is even number. That means we can use Simpsons 1/3 composite. Okay. So here you need to write back from 0 to 0.7. Okay, we have function dx. Okay, you need to write d is equal to, you can see when you use Simpsons 1/3 for the first 4 segment, okay, the limit will be from 0 to 0.4. Okay, from 0 to 0.4. Okay, fx dx. This one you use 1/3 rule. Okay, plus, and then for 3, 8 rule, we start at 0.4, 0.4 to 0.7, fx dx. This one we solve by using 3, 8 rule. Okay, so that's all for integration by using numerical method. Okay, so we have 2 rules. We have trapezoidal. Okay, trapezoidal single is n equal to 1. Composite can be even and odd. Tak ada masalah for trapezoidal. Okay, but for Simpsons, we have Simpsons 1/3 and we have Simpsons 3, 8, and we have combination with Simpsons 1/3 and 3, 8. Combination or in tandem, we use when n is odd, but n is not 3. Kalau 3, n odd but n equal to 3, we use 3, 8. Okay, but when n is odd but not equal to 3, that means more than 3. Okay, and odd, we need to use 1/3 and 3, 8 in tandem. Okay, so far ada soalan tak? Ada soalan?
Tak ada, madam.
Tak ada ya?
No, madam.
Alright.
Ada, madam.
Okay, so kita solve soalan ni. Yang ni you all dah cuba atau belum lagi? Ada yang dah cuba?
Dah, madam.
Dah. Okay, yang dah cuba boleh check jawapan. Ada yang belum cuba lagi?
Saya belum cuba.
Belum lagi. Okay, kalau belum lagi you kena buat sekarang lah. Kita buat sama-sama. Okay, so look at the first question. Evaluate from 0 to 0.8. Okay, so 0 tu is A, 0.8 is B. The limit from A to B. Okay, so here you have to use by using trapezoidal rule. First, what you need to do is you have to identify what is your function, what is your A, and what is your B. Function is any equation, okay, between this notation, between symbol ni, that is your function. Okay, so in this case, your function is this one, equal to 2x squared e 2x. A is 0 and B is 0.8. Okay, so saya, sekejap ya. Saya solve pakai note. Okay. Yang ni untuk kelas yang sebelum ni. Okay, tapi saya tulis yang baru. Okay, so first, we have to solve from 0 to 0.8 2x squared e to x dx by using trapezoidal rule. Okay, so here dia tak mention n is equal to apa, dia tak mention n berapa, tak ada, dia tak mention h equal to berapa. So we assume this is single. Yeah, single trapezoidal rule. Okay, so you have to refer to the formula of single. Okay, the formula is given by, you tengok balik nota. Okay, formula you tak payah hafal. Okay, formula semuanya kita akan bagi dalam appendix. Okay, formula for single trapezoidal rule is given by I equal to I is integration. Okay, from h over 2 in bracket FA plus FB. Okay, so what is H? H is, okay, let's say when you plot, kita tak perlu plot cuma I sketch nak bagi you all nampak. Okay, let's say this is the function of fx. You have to integrate from 0 to 0.8. Okay, H is the distance between this. D is your H, distance. Okay, between the first point and the next point. Okay, in this case, you can see that our H is 0.8, right? Okay, so you write 0.8 divided by 2. And then F, when you substitute A, okay, what is our A? This is our A. A is 0. Substitute 0 into the function. Plus F when you substitute B. What is B? D is A, D is B. B is 0.8. Okay, now what is our function? Okay, function x is equal to 2x squared e to x. Okay, this is our function. Okay, now you have to substitute 0 into the function. Okay, so our x is 0 equal to 2. Our x, you substitute with 0. Square e to x is 0. You will get 0, right? Okay, so this is 0.8 over 2 in bracket 0 plus, now f when you substitute 0.8. F when you substitute x with 0.8, you will get to 0.8 square e 2 times 0.8. Okay, calculate. You dapat berapa? Okay, substitute 0.8 into the function. You will get
6.34.
4 decimal places.
6.3399.
Okay, good. 6.3399. Okay, in numerical method, always at least 4 decimal places, yeah. Unless dia inform, dia mention kat situ berapa decimal places, you can follow lah. Sometimes 6, but usually we will do 4. Okay. Now substitute into here the formula, you will get 6.3399. Okay, now calculate. 6.3399 plus 0 times 0.8 divided by 2. You will get 2.5360. Okay, so do you get this answer? Dapat tak?
Yes.
Dapat, madam, dapat.
Okay, so you will get this. Alright, now we refer to the next question. You have to solve by using trapezoidal rule with h equal to 0.2. Okay, now you can see here, same, solve by using trapezoidal rule, but now given h equal to 0.2, that means from the first point to the next point, the distance is 0.2. Okay, so this is number 1. Okay, 6 betul. Okay, we use trapezoidal rule. Given h equal to 0.2. Okay, maksudnya, let's say this is our function. You have to integrate from 0 to 0.8, right? Okay, because our integration is 0 to 0.8, we have to x square e to x ds. Okay, but the distance between 2 points is 0.2. Maksudnya from 0, the next point here is 0.2 sebab distance dekat sini is 0.2. Okay, we have this segment. Okay, and then from 0.2 you plus another 0.2 dekat sini. Okay, so here will be, the next point will be 0.4, right? And then we have this one, the distance is 0.2, h is the distance, h. And then h equal to 0.2, we will get the next point is 0.6. And then here, we need to add h equal to 0.2, the next point is 0.8 and then we stop because we have to integrate from 0 to 0.8. Okay, so you need to count how many segments that you will get when h is 0.2. Okay, you can see you have segment, berapa segment? N equal to?
4.
4. Yeah. 1, 2, 3, 4. That means n equal to 4. Boleh? Okay, when h equal to 0.2, that means from 0 to 0.8, kita ada lagi point. Okay, between 0 to 0.8. Okay, but the distance between 0.8 is only the distance between each point needs to be 0.2. Boleh? Okay, yang ni semua faham tak macam mana kita dapat? Macam mana kita boleh dapat ada point baru ni? 0.2, 0.4, 0.6.
Faham.
Boleh, madam.
Faham ya? Okay. So, when n equal to 4, that means we have to use formula trapezoidal rule composite. Okay, composite trapezoidal rule, if you refer to the formula, okay, I is equal to h over 2, and then we have f x naught that means the first point, plus f xn that means the last point, plus 2 times the sum of I equal to 1 to n minus 1 f xi. So the formula is given by this. Okay. So before you apply the formula, okay, we label the point. Okay, we start this with s naught, x1, 2, 3, 4. You can see when n equal to 4 segment, here the last point is x4. Okay. Okay, next. Sorry. Okay, next. We know our h is 0.2 over 2. And then we have f when you substitute 0. Okay, x naught is the first point. Point yang pertama. Okay, ni point yang pertama. Ni point yang terakhir. Okay, and then yang color hijau ni point yang tengah-tengah. So, plus f Sn, n, our n is 4, so x4, 0.8. The point is 0.8 plus 2 times summation. Okay, kita ada summation kat sini, start I equal to 1. Bukan I kosong yang saya tak salah tu. Yang ni salah. Saya ganti dengan yang ni. Start dengan 1. Okay, maksudnya kat sini f(x1), Okay, lepas 1, fx2. After 2 dekat sini, our n is 4 kan? 4 minus 1 is 3. Plus fx3. And then we stop. Okay. Jadi kita tengok x1, x1, x2, x3 is the point between the first and the last one. Right? Okay, maksudnya you kena substitute point yang seterusnya 0.2, 0.4, 0.6. Okay. Faham? Boleh faham? Okay, jadi boleh ya? Okay, jadi senang you create table, you masukkan x tadi, xi, fxi. Okay, yang I ni you boleh tulislah. I kita start dengan 0, 1, 2, 3, 4. Yang ni nilai I. Okay, xi bila x kosong, when I 0, x kosong nilai dia 0. X1, okay, yang ni x1 0.2, x2 0.4, x3 0.6, x4 0.8. Okay, and then yang kolom yang ni, bila you masukkan F0, you dapat berapa? Kita dah kira tadi 0. Bila kita masukkan X equal to 0.8, yang ni pun kita dah kira tadi. Yang ni kita kira tadi, when X equal to 0.8, substitute into the function, you will get 6.3399. Okay, so you tak payah kira dah. Okay, now you have to substitute what is F0.2. You kena kira. F0.4, F0.6. Okay, calculate. Kira yang ni. Okay, substitute 0.2. You will get. Ada yang dah kira?
0.1193.
Okay, 0.1193. Okay, substitute 0.4.
0.7122.
0.7122. Okay, 0.6.
2.3905.
2.3905. Okay, now we substitute into the formula. We will get 0.2 over 2 in bracket. F0, 0, F0.8, 6.3399 plus 2. Okay, kita kena kira sum dalam bracket tu. 0.1193, 0.1722, 2.3905. Okay, you kira sum in the bracket times 2. Okay, and then calculate what is our final answer.
$1.2784.
Okay, 1.2784. Okay, you can see that difference method. Okay, you will get a bit different the answer. Okay, trapezoidal rule single, you will get 2.5360. Trapezoidal composite trapezoidal, you get 1.2784. Okay, so kalau you baca, you can see that composite trapezoidal, the answer is more accurate, compared to the single trapezoidal rule. Okay, semua okay? Sampai trapezoidal rule?
Okay, madam.
Alright.
Okay, madam.
Okay. Now we look at solve by using Simpson's one-third. Okay, dekat sini dia tak mention n is equal to what, or dia tak mention h. Okay, tak ada mention h, tak ada, n pun tak ada. Okay, kalau tak ada, that means this is Simpson's one-third single. Okay, what is single Simpson's one-third? Simpson's single one-third, dia kena 3 point. Kalau trapezoidal, ada A dengan B dah cukup dah for single. Okay, kalau you nak divide lagi, tak ada masalah. Okay, Simpson's one-third pula, kalau single, include titik A, B and one more is the midpoint, which is C. So, this is single. Okay, here, not mention H, tak mention, N tak mention. That means here, our N is equal to 2. Single. Okay, because we need to include middle point between A and B. Okay, so number 3. Okay, number 3. We have to solve by using Simpson's rule. Okay, Simpson's rule. Ni the function, the integration from 0 to 0.8 to x squared e to x dx. Okay. So we have the first point 0, the last point 0.8. Okay, the middle point berapa? Titik tengah?
0.4.
Yes, 0.4. Dia kena tengah-tengah. Okay, so you can see when we include middle point, we have n equal to 1, n equal to 2. Okay, we have 2 segment. Okay, ataupun ni salah. Yang ni, we can write here, first segment, second segment. Okay, so we label our point first. This is our first point, x0, x1, x2. Okay, refer to the formula for Simpson's composite. The formula is given by I equal to, okay, I equal to single trapezoidal, composite trapezoidal. Okay, Simpson's one-third. Okay, the formula is given by h over 3 in bracket fx0 plus 4fx1 plus fx2. Okay, ni formula Dia bagi yang ni. Okay, so what is our h? H is distance between 2 point. Daripada first point ke point yang seterusnya, you can see what is our h? H kita berapa?
0.4.
Yes, that is our h, 0.4. You can see here also h 0.4. So you write 0.4 over 3. Okay, now you can see fx0 is f when we substitute 0. Okay, 4 times f when we substitute 0.4 plus f when we substitute 0.8. Okay, we can refer the same table yang ke atas ni. Kita refer this table. Okay, 0.4. Fx0 is 0. 4 times 0.4. 0.7122. And the last point is 6.3399. Okay, you don't have to calculate. We just refer the same table dalam composite trapezoidal rule. Okay, now calculate. Okay, dapat berapa?
1.22512.
1.22? 52 ke 55?
52. 1.2252.
Yes, 1.22.
52.
Yes, 1.2252. So you will get this. Okay. Now we look at the next question. Okay, yang lain-lain boleh follow tak?
Boleh.
Boleh, madam.
Okay. So the next question. You have to use Simpson's one-third rule with H equal to 0.2. Okay, now given H is equal to 0.2. Number 4. Simpson's rule with H equal to 0.2. Yang ni pun sama dengan yang trapezoidal tadi. Bila you divide, when the step size is 0.2, we have 4 segment, right? Dia sama macam ni. Okay, we will have 4 segment. 4 segment, that means our n, it will give us n equal to 4. Okay, so we refer to the formula. Salah ke? 2x square. 2x square. Okay. Okay, next. The integration is given by h over 3 f x naught. Okay, f the first point plus f the last point plus 4 times. We have sum from I start with 1. And then you can see yang bawah ni 3, 5 dot dot dot. That means this one is for I odd. Okay. N minus 1 FSI plus 2 I is start with 2 and then we have 4, we have 6 dot dot dot. That means this one when I is even. N minus 2 FSI. Okay. Jadi kalau you all tengok dekat sini. Okay, jadi saya sketch sekali lagi. Okay, katakanlah dia is 0. This is 0.2, 0.4, 0.6, 0.8. Okay. Kemudian you label. Label. This is our x0, x1, 2, 3, 4. Okay. So yang color kuning ni saya buat. This is for the first point, the last point. Okay. So kita boleh tulis. Equal to H kita tahu 0.2 over 3. The first point 0, the last point 0.8 plus 4. Yang ini adalah untuk odd plus 2 sum of I when I even. Okay. So yang color biru kita ambil untuk I odd. I odd kita ada X1. Kita boleh biru. Hijau. Okay. I odd, you can see kita ada X1. 1 is odd, 3 is odd, right? I1, I3. I equal to 1, I equal to 3. So we have 2 odd. Okay, so we can write F 0.2 plus F 0.6. Okay. Plus 2, kita ada tinggal satu lagi point, 0.4. 0.4 I equal to 2. Okay, you tengok dekat sini. Kita ada lagi satu point, 0.4. 0.4 x 2. 2 is even. Okay. So, in the bracket, we can write times F 0.4. Okay, faham tak?
Faham.
Yang lain-lain faham?
Faham.
Faham ya? So, now we substitute the value. 0.2 over 3. 0 plus, yang ni tak ingat dah. Okay, refer to the table. 6.3399 plus 4 dalam bracket ni 0.2. Okay, you refer table. .6 plus 2 times okay, now we can solve.
Madam,
Ya.
kenapa yang even tak ambil X4?
Kenapa even tak ambil X4? X4 tu last point.
Oh, kalau last point tak payah ambil?
Tak, sebabnya kita dah include dah titik tu.
Oh, okay.
Sebabnya dalam formula ni you kena ambil the first dengan the last tu. Okay, you kena ambil first dengan last kita dah masukkan dah dalam formula. Jadi yang the rest tu between the first and the last, you kena identify I tu odd ke even untuk masukkan dekat 4 times ataupun 2 times. Ya. 4 times this or 2 times this depends on I between the first and the last point. Okay? Okay, siapa dapat jawapan boleh bagi tahu.
1.1869.
Okay. 1.1869. Yang lain dapat?
Dapat.
Okay.
Dapat.
1.1869. Okay. So, let's say for the Simpson's wanted rule, the formula is given by yang ni je. Simpson's wanted. Sorry. Sekejap. Okay, let's say dia cuma bagi satu formula je. Okay, untuk Simpson's wanted, which is dia bagi you yang ni. So, you can use for single, you can use for composite. Okay, composite tak ada masalah lah. You dah pakai tadi kan. Tapi kalau Simpson's single, you tengok dekat sini, kita ada 3 point je. Okay, point yang pertama 0x0. Point yang kedua x2. Okay, that's why you ada fx0, fx2. F the first point plus F the last point. Okay, yang tengah-tengah you tengok nilai dia odd ke even number? Tengah-tengah tu.
Odd.
I dia odd.
Odd.
When I is odd, that's why times 4. Okay. When I is odd, that's why we times with 4. Sebab dia tak ada even. Okay, sebab tu dia bagi formula yang macam ni. Tapi if Simpson's rule single, the formula is not given, you will use the general formula for Simpson's 1/3. Okay, faham? Boleh ya? Okay, now the last question. Soalan last, evaluate from 0 to 0.7. Okay, sekarang ni dia tukar limit. Okay, you kena integrate, okay, from 0 to 0.7. Dia tukar. Okay, and then Simpson's rule with h equal to 0.1. Okay, now try to identify how many segments that we have. Okay, you sketch, you tengok ada berapa segmen, how many segment that you get.
Seven segment.
Okay, 7 segment, right? 7 segment. Ya, aku ni. Sekejap. Okay. Alright. Simpson's rule with h equal to 0.1. Okay, you have to integrate from 0 to 0.7. The same function. Okay. So first you have to identify how many segments that you have. Okay, kita tahu we start with 0 and then the next point, the distance is h equal to 0.1. That means the next point is 0.1. And then 0.2. Ya, tak cukup lah. Okay, so sini 0.1 and 0.2. Okay, and then we stop at 0.7. Okay, so you can count. You have 1, 2, 3, 4, 5, 6, 7 segment. N equal to 7. Okay, when n equal to 7, we know that we cannot use Simpson's 1/3 because Simpson's 1/3 composite always n even. And then you cannot use Simpson's 3/8 rule because n is equal to 3. Okay, so what we can do is we need to use 1/3 and 3/8 in tandem or we combine. Okay, so you can choose the first 3. Okay, mula-mula you kena choose 3/8 dulu because we know 3/8 is n equal to 3. Okay, you can choose the first 3 or the last 3 by using 3/8. Okay, katakanlah kita okay, kalau you choose the first or the last 3, the answer will be slightly different. Okay, tak sama. Jawapan you dengan kawan you takkan sama. Dia ada lain sikit lah. Okay, but let's say we choose the first 3, we use 3/8. Okay, because kita nak compare jawapannya. Okay, let's say we choose the first 3, we use 3/8. Maksudnya yang ni kita pakai 3/8. So our integration from 0 to 0.3, we will use 3/8. And then from 0.3 to 0.7, we will use 1/3. Okay, so we write the formula. Okay, you need to rewrite. This integration is equal to, we separate into 2 integration. from 0 to 0.3 to x squared e to x dx plus from 0.3 to 0.7 to x squared e to x dx. Okay, we separate. Okay, we separate to integration. Okay, first we use 3/8 and then plus when we use 1/3. Okay, now refer to the formula. Okay, kita tengok formula 3/8. Okay, formula 3/8 is given by 3h over 8 okay, this is formula 3/8. Okay, plus formula for Simpson's composite 1/3. Kita tak ada 3 kan, kita terus H. Okay, you refer formula. Empat, yang ini saya tulis sum. Sorry.
Apa ni?
Tu bunyi apa tu? Yang ni saya tulis I odd ya. I odd. I even. Okay, so yang atas ni adalah formula untuk 3/8. Yang ni adalah formula untuk 1/3. Okay, so before we use the formula, you need to label your point. Okay, kita label point dulu. Point yang pertama, kosong ni is x0, x1, x2, x3. Okay, ni untuk 1/3. Okay, untuk this one is for 3/8. Okay, and then we label point for 1/3. Okay, this is x0 for 1/3, x0. Okay, now kita masukkan nilai. Okay, so sama dengan equal to 3, we know h is 0.1 over 8. F yang terakhir, sorry 3. Saya tengok formula salah. Kita tengok formula yang atasnya untuk 3/8. 3 times h is 0.1 over 8. Fx0 titik yang pertama which is 0 plus 3 times fx1. x1 is 0.1 plus you tengok formula yang atas ni and then plus 3 fx2, our x2 is 0.2 plus fx3. fx3 is f0.3. Okay, plus kita tengok formula yang bawah ni pula, h over 3, 0.1 over 3 in bracket. Fs0 adalah first point which is 0.3. The last point is 0.7 plus 4. Okay, dalam bracket ni adalah nilai-nilai yang odd. Odd ada berapa? Ada 2. 1 dan 3. Betul tak? Odd x1 dengan x3 which is f0. (0.4) plus 0.6. Okay, plus 2 times even. Even ada berapa? Even ada satu je, X2. Okay, which is F 0.5. Okay, boleh? You tengok kita dah masukkan semua titik. 0.3 ada, 0.4, 0.5, 0.6, 0.7. Semua titik kita dah masukkan dah. Okay, faham tak sampai sini?
Faham.
Okay, bagus. Okay, now kita nak masukkan nilai. Okay, masukkan nilai 3, 0.1 over 8. And then F0 kita tahu 0 times, okay 0.1 kita tak pernah kira lagi. Okay, you tengok yang mana yang tak pernah kita substitute in function. Kita tak pernah masukkan dalam function. Yang ni tak pernah. So you have to calculate. Yang ni you masukkan dalam function.
Madam,
Ya.
yang kena darab dengan 4 tu kan yang untuk odd ke? Odd kan 0.5 ke?
Sekejap. Odd, you tengok ni. Yang you label titik tu. Odd. Okay, you tengok yang ni. X1, X3.
Oh, okay.
Sebab student memang selalu buat mistake yang tu. Dia confused. Okay. So, between yang ni, the first and the last point, kita ada 3 titik. X1, X2, X3. Okay, 1 dan 3 adalah odd. X2, 2 adalah even number. Ya. Yeah? Okay, now masukkan nilai dalam function 0.1, 0.3 tak pernah kira lagi. 0.5 tak pernah kira lagi. 0.7 pun tak pernah kira lagi. Okay. So, you kena masukkan nilai. Macamnya saya... Okay, you kira dulu ya. Kira dulu. Okay, 0 kita dah pernah kira. 0.2. 0.4. (0.6) Okay, jalan lain you kena masukkan lah. 0.1 bila you substitute you will get 0.3, 0.5, 0.7. Okay, now substitute into the formula. Okay, saya kira kat sebelah ni. Senang nak refer. Siapa dah dapat jawapan bagi tahu? Okay, siapa dah dapat jawapan?
Kosong poin 6653.
0.6653.
6653.
Yang lain? Dapat ada error tu.
0.6762.
Yes, 0.6762. Okay, you boleh semak. Yang ini you pakai. Okay, yang ni kita pakai 38 and then this one is 1/3 ya. Okay. So yang 38 you check balik jawapan you dapat tak 0.0285. Yang bulat merah yang kedua tu 0.6477. Total up 0.6762. Okay, yang lain-lain ada yang dapat sama 0.6762?
Dapat sama.
Okay, good. Alright, good. Okay, so that's all for chapter 5, numerical integration. Okay, so after this, I hope you can watch video chapter 6. Okay, chapter 6, solving differential equation. Okay, satu solve single equation je. Okay, satu lagi solving two equation. Okay, if we have more than one equation, we call system. Okay. To solve single, we have method Euler, we have RK2, Runge-Kutta 2 and RK4, Runge-Kutta 4. Okay, Runge-Kutta tu you ada macam-macam cara ni lah, the way orang pronounce tu ada panggil Runge-Kutta lah, Runge-Kutta lah. So it's up to you lah unless you know that is the method yang we are referring the same method. Okay, so for single, you should know how to solve by using Euler, RK2 and RK4. RK2 we have three method. We have Hume, Midpoint and Rosten. Tiga. Tapi video tu tak upload lagi. Dalam kalam, we only have RK4 and Euler. Yeah, RK2 insyaAllah by this week or next week. And then solving system, you should know how to solve by using Euler and RK4. Okay. So starting from next week, we will discuss final exam question. Okay. Kita akan discuss daripada chapter 3. Okay, sama kita akan discuss iterative method, non-linear, system non-linear, chapter 3. And then chapter 4, kita akan discuss Newton-Lagrange inverse, spline and piecewise. Okay, chapter 5 kita dah discuss yang ni, tapi kita boleh tengoklah a few lagi contoh. And then chapter 6, solving differential equation with IVP. Saya akan pick dua sampel soalan final. Okay, saya akan share, kita akan discuss starting from next week. Okay, so make sure you can understand yang chapter 3 tu. Chapter 3 you kena faham iterative dengan non-linear. Okay, and then chapter 4, chapter 5, chapter 6. Okay, yang chapter 7 kita ada dua soalan, shooting dengan FDM. Okay, yang tu maybe after next week lah ataupun 2 minggu lagi you akan belajar yang tu. And then kita akan discuss lah. Okay, nanti saya akan share dalam group contoh, saya akan ambil sampel soalan final untuk kita discuss starting from next week. Okay? Ada soalan?
Tak ada, madam.
Tak ada semua okay?
Okay, madam.
Alright, okay. So that's all for today. Okay, so thank you. Bye-bye.
Thank you, madam.
Alright,
Thank you, madam.
Thank you, madam. Thank you, Amin.
Thank you, madam. Okay, welcome. Okay, siapa yang baru masuk tu sorry kelas dah habis dah. Nanti I share dia punya solution untuk soalan.
Thank you, madam.